Good morning and welcome to today's mini lecture. Today we are going to be looking at how to determine the chemical formula for a hydrate. So I went ahead and wrote a hydrate up here on the board, and before I do that I want to go over just a little bit of review. We've talked a little bit about hydrates. I want to make sure that everybody remembers what a hydrate is. So first of all, a hydrate is nothing more than an ionic compound that doesn't have enough internal structure to support a crystal being repeated. So what happens is, in a crystal, you get that repeating pattern. It starts stacking up and stacking up and stacking up. Well, most of the time, an ionic compound will have enough strength or internal support to allow it to keep stacking and keep stacking. But sometimes it doesn't. So it starts stacking and stacking and stacking. It gets so heavy, so much pressure that it just collapses in back on itself. So what happens is it has to incorporate water molecules in these hydrogen bonds and uses that to help create more internal structure support. So how many water molecules? In this particular hydrate, I know that there's 10 water molecules. So if I want to go through and I want to name the hydrate, then it is a combination of our two sets of rules for ionic and molecular. So I'm going to name my ionic part exactly the same. So this is called sodium. So I'm going to write that down. Since the metal is not a transition metal, I don't have to worry about any types of Roman numerals or any of that. I look at CO3 on my polyatomic ion table and I see that it is a carbonate. So I have sodium carbonate. All right, now we're going to look at this. Let me repeat that. We're going to look at the number and we're going to use a prefix for it. So 10, we know that that's a deca. And we know that this is called a hydrate. So as I go through and I look at this, this is sodium carbonate deca hydrate. Now, how did I get that 10 up there? Well, just like in our mole-mole ratio, we talk about the subscript numbers here. We can also look at the coefficient numbers here, which are the big numbers, and that's a 1 to 10 ratio. So I can use that same mole-mole ratio to now go back in and determine what my formula is. So I'm going to go through and I'm going to look at two example problems, and they're very similar to each other, and I just want to go through and work these. It says if you have a hydrate of NiSO4, so it has an original mass of 1.04 grams and you heat it slowly to remove the water. Remaining mass of the anhydrous is 0.61 grams. Determine the chemical formula of the hydrate. So the way that I set this up is I'm a very visual person, so I like to write it all the way out. I'm going to start with NiSO4 H2O. So I do not know that number right there, but I do know that this is the whole hydrate, and it tells me that I'm going to start with 1.04 grams of the whole hydrate. So I know that when I start, I have 1.04 grams of that. Now, it also says that I heat it up, and y'all know that if you heat it up, the water is going to evaporate out, and it leaves me with what is known as an anhydrous. The prefix an, like antebellum, it just means no or not, so no water. So I'm just looking at this right here. So that is my anhydrous, not with the water, and it says that it is 0.61 grams. Just like in our chewing gum lab, we can now figure out what is going to be the mass of just the water. Well, I know that's the total mass, and that's the part of the mass. So if I subtract 1.04 by the 0.61, I'm going to get 0.43 grams. So this is setting everything up so that I can now look at this and say, look, I can set this up to a mole-mole ratio. If I start with 0.61 grams of NiSO4, I can convert that to moles over grams. This is my mole map. That the relationship between a mole and a gram is the molar mass. So I'm going to have to determine the molar mass of NiSO4. So my nickel is going to be, and I already have it worked out, so I'm going to look at my notes, 58.7. Oxygen is 16.0, and I'm sorry, oxygen, let's do the sulfur in order. Sulfur is 32.1. Oxygen, I have 4 of them at 16.0, so that's going to be 64. So when I add these together, I get the total molar mass to be 154.8 grams per 1 mole. So now I can go through and just simply say, when I divide these out, I'm going to get 0.00394 moles. I'm going to make sure I got that. Yeah. So, guys, big thing here is a lot of us, we say 3 numbers and you'll put 0.003. That's not counting those first zeros that are just placeholders. So it's 3 non-zero numbers. So I've got a 3, a 9, and a 4. That gives us enough significant figures to actually come out with a better answer. So I'm going to come over here now and say 0.43 grams, and this is of just the water. And I'm going to put a mole to a gram. This time I'm going to use the molar mass of water. I know what that is. One oxygen is 16 and 2 hydrogen is 1, so I'm going to put 18.0 grams per 1 mole. Now, this time whenever I divide it out, I get 0.0239. So that's going to be my moles. So I still have to set it up to a mole-mole ratio. So I've not got my mole-mole ratio, just like we did on our empirical formulas. Exact same thing. You're going to divide by the smallest one. And in this case, it's 0.00394 and 0.00394. So when I do that, number divided by itself is going to be 1. Now, if I plug this one in, I'm going to see that this number is going to be 6. So what happens is I'm going to have a 1 to 6 ratio. So this is going to be my nickel 2 sulfate, and then 6 is hexahydrate. So what I want you to see out of this, and before I go any further, is that if we know the masses of each one of these, which we do, we can take those masses using the molar mass and convert them to moles. If you know the moles of each one of them, we can set it up as a mole-mole ratio. Once you set it up as a mole-mole ratio, that'll take your salt here, and put it as a 1, because you're dividing by the smallest one. And then it'll give you a whole number for the water. All right. I'm going to stop right here, and then I will make another video to finish the second problem. All right, thank you.